Good day. Here's lesson 5.6, fundamental theorem of algebra. And really this is nothing new. I've already shown you how to do these types of problems. We're just going to really be hammering it in. All the fundamental theorem of algebra states is if you've got a polynomial of degree that's 1 or bigger, then you have exactly n roots when you set it equal to 0. And so we've already talked about this. This right here would have how many roots? It would have 3 roots because the degree is 3. So now, what kind of roots are they? I don't know. We're going to have to do some factoring in order to figure out here. They might be real roots, might have some imaginaries. Remember, the imaginaries come in pairs though. So this one right here, you'd either have 3 reals or 1 real with 2 imaginaries. When we get down, when we get down to factoring it. So when we factor it, we can come up with 3 different real ones, or 1 real with 2 imaginaries, because you can't have an odd number of imaginaries. All right. So how are we going to do this problem? Well, a couple ways. You can actually group this problem, and if I don't tell you you can't group, feel free to group. So if you see that you could take an x squared out and make it 3x plus 2, and then realize that you have to take a negative 36 out of these two to get 3x plus 2. You're going to be in business. That turns into x squared minus 36, 3x plus 2. You can factor more if you need to, otherwise you should be able to tell me what the roots or zeros here already. The roots or zeros are plus or minus 6. And then negative 2/3. So there were 3 real roots on this one. If you didn't recognize that that was groupable, you go to your calculator and think about your possible roots. Remember, your possible roots would be the factors of 72 over the factors of 3. So you'd have a 1, 3 here, and then 1. There's a lot of numbers that go into 72. There's 1, 2, 3, 4, 6, 8, 9, 12. I'm missing a couple here. 24, 18, 18, 24, 36, 72. There's a whole pile of them. Remember, we're going to use our calculator to zone in on them. So I've already punched in my calculator. I have it highlighted, ready to go. It's Y3 on this one, so I'm going to go ahead and graph. And you can see on my graph that it hits in 3 spots. And it sure looks like it's hitting at negative 6 and 6. This one, I'm not sure what it is, but based on my answer over here, it looks like it must be negative 2/3. So I know 6 and negative 6 look pretty good. You can verify 6 and negative 6 by hitting the table, going second graph, and going, hey, look, if I go to negative 6, I get 0. So that's where it hits the x-axis. But what you can do then is go ahead and use negative 6 and plug it in synthetically. Make sure you get 0 at the end. In this case, I do. And then once you get down to a quadratic, which this is, because I started with x to the 3rd, so this would be 3x squared minus 16x minus 12. Once you get to the quadratic, go ahead and say, all right, I can either factor that or use the quadratic formula. Well, factoring it's not as bad as it was in chapter 4 because I got a pretty good idea what works. I'm supposed to get positive 6, so I'm pretty sure x minus 6 is a factor. This one up here would give me a factor of x plus 6. Keep that in mind. What I put in up here is the opposite of the factor. So x minus 6, what would I have to do in order to get a 3x squared? I'd have to put a 3x right here, because then x times 3x is 3x squared. And what would I have to put at the end to get a minus 12 at the end? I'd have to put a plus 2, because negative 6 times 2 is negative 12. Now you don't want to verify, excuse me, you want to verify that you've got the right middles. Do your outsides and insides here, and make sure that you get negative 16. Which we do. We get 2x, and negative 18 is negative 16. So that's proving that the zeros work. This negative 6 was proved because I got a 0 at the end. And then when I factor these, I can go ahead and say, I know that these are zeros based on my factors. Example 2. Well, this one, that doesn't look groupable. Okay, it's got 6 terms, it's to the x to the 5th, so it's a quintic polynomial. I'm going to plug this in my calculator and see if I can narrow down my zeros to try, and then I'm going to use synthetic again until I get down to a quadratic. To get down to a quadratic, I'd have to use the synthetic 3 times, because it would go from x to the 5th, down to x to the 4th, down to x to the 3rd, down to x squared. So I'm hoping I can find 3 zeros. So let's see if I can get this one in my calculator. Y equals. That one I have typed in y1. So all I have to do is activate y1. I'm going to arrow over to the equals, press enter. I'm going to arrow down to y3, press enter, and get that turned off. So now I'm only graphing y1. Graph. And it looks like this one crosses at, well, it actually crosses at 4 spots. I shouldn't say crosses. It crosses here, it crosses here, it crosses here. Right here, it's hard to tell, but if I zoomed in, you'd see that that is a bounce. So, I don't know if you remember, what happens when you have a bounce? That means you have 2 of the same root. So, it looks to me like I have 3 as a root, I have -1, but because it bounces, it means I probably have another -1. This one looks like -2, and this looks like -3. We'll go ahead and check that. Second graph, make sure that those actually work. Here I see I got -3, -2, -1. All are zeros, and 3 is also 0. So they're all looking good. So now I just need to actually show it. I don't want you going, oh, my calculator said so. We're going to show, that out of here. We're going to show synthetically that they work. So again, what do we think worked? We thought we had -3, -2. We thought there was -1 with multiplicity 2, and then 3. So let's go ahead and get the synthetic going. It'd be 1, 4, -4, -34, -45, -18. I'm going to plug in the -1 just because working with 1 is a lot easier. So that's going to be 1, -1, 3, -3, -7, 7, -27, +27, -18, +18, 0. So again, I want to get down to x to the 2nd. I've got, this would be x to the 4th, what I have right here. So I'm going to keep going. This next one will give me x to the 3rd. I'm pretty sure -1 occurred twice. It looked like a bounce. So I'm going to put -1 again, just because it's nice to work with. We'll shoot the synthetic. And make sure I get 0 at the end. If I don't get 0 at the end, let's go back. Make sure I didn't make any mistakes in my adding and multiplying. I'm going to go one more time because now I'm down to a cubic. You really wouldn't have to here because I don't know if you can tell, but I can tell that this is 4 terms, and that's actually groupable. If I were to take a -9 out of these, I'd get 1 and 2, and that would match up with those. So that is, you could stop there and group and finish by grouping, but I'm going to go ahead and do synthetic one more time and get it down to a quadratic, and then factor from there. Okay, so let's use -2. 1, -2, 0, 0, -9, 18, 0. You wouldn't have to use -1, -1, -2. You could have used any of the 3. You'll still get the same answers. You just have something different to factor at the end. I ended up with x squared minus 9, which of course is a square minus a square, which turns into x plus 3, x minus 3, which gives me zeros of -3 and 3. So you have shown me that -1, -2, you show me those work up here by getting 0 at the end. And then you show me that -3 and 3 work by factoring. And that's what I'm looking for on these problems. Example 3. This one, you've got a couple of different ways you could do it. You might say, I'm going to factor out a 2. And then you might recognize, hey, that's a cube minus a cube. 125 is 5 cubed. And we got our cube minus cube pattern, which you just write down what's in your face without the cubes, x minus 5. And then you do first one squared, opposite of the product, last one squared. What makes these equal 0? Well, 5 makes it equal 0. And then how do I figure out what makes this equal 0? Well, you'd have to do the whole quadratic. If you do the quadratic there, you'd have negative 5 plus or minus the square root of 25 minus 100. If I did 4ac all over 2. Well, that simplifies to negative 5 plus or minus 5I root 3 over 2. And why is that 5I root 3 over 2? Because negative 75, oh, excuse me, I need that camera. Negative 75 is the discriminant on the inside there. And that would turn into 5 root 3. But you got it's a negative, so you need the I. So that was one way to do that one. Another way, which is kind of cool, in case you forgot the pattern, the cube minus cube pattern, you could do this synthetically. You could put in your calculator and say, hey, it crosses at 5. It better cross at 5 because that's one of our zeros. So it crosses at 5, and I'm going to put my 2. And then remember, you got to put spaces here. You got to put zeros in. So I had x to the third for 2, and then I add no x squareds and no x's, and then a negative 250 is a constant. Now, if you go ahead and do synthetic here, you will see that there's a 0 at the end. You're left with a quadratic, which is 2x squared plus 10x plus 50. This right here tells you that a factor is x minus 5. Right? If 5 is a 0, then x minus 5 is a factor. And then also, these are all even, so you could take a 2 out. I'm going to put it way in the front. And if I take a 2 out of all these, I would get x squared plus 5x plus 25, which is the same as what we had over here. So if you happen to forget your cube minus cube or cube plus cube pattern, you could actually remind yourself how to do it by using synthetic. Synthetic will get it done for you. Okay, last one, just one more. You might want to try this on your own. See if you can get it and then check in with me. And go ahead, use my calculator. Y equals, this isn't my first one. I got to turn the first one off. And I've got it typed in as Y4. Press enter, graph. Looks like it hits at negative 3 and 3. And that's good because I only need 2 roots. Because I got to get from x to the 4th down to x squared. So I need 2 roots. So I'm going to try 3. 1, 1, negative 7, negative 9, negative 18. And I'm also going to try negative 3 later. And those are possibilities because they are both factors of 18. You know, you put your 18 over 1, or your 9 over 1, or your 6 over 1, or your 3 over 1. And you do plus or minus. So this should work. 3, 4, 12, 5, 15, 6, 18, 0. Okay, I'm down to a cubic, and that wouldn't have been groupable, so I definitely have to keep going this way. Negative 3 was the other one I thought. So 1, negative 3, 1, negative 3, 2, negative 6, 0. So if I were going to factor this, I'd have factors of x plus 3 for this one, x minus 3 for this one, and then this other one would be x squared plus x plus 2. That's what this is. The zeros are negative 3, 3, and then how do I get the zeros of this? Well, I got to do the quadratic. So I do a negative 1 plus or minus square root, 1 squared minus 4 times 1 times 2, all over 2 times 1. Negative 1 plus or minus square root of negative 7, 1 minus 8, all over 2. And that simplifies to negative 1 plus or minus I root 7, all over 2. So that's kind of putting it all together here, showing how synthetic is valuable, synthetic division, synthetic factoring, so that we can find zeros of something that of polynomials of greater degree with many, many terms when there are no other options. I'm going to stop here. There's word problems. I'm going to put those on another video. Thanks for watching. Have a great day.